Excellent.
More!
I actually have no idea what the first one is.
I heard everyone sing.
Well, I thought I heard one or two other things in there also, but at exactly the same time. So that's why I had to do the redo, or the do-over. Okay, lesson 89, conjunctions. Now, in language class, what is a conjunction, and what does it do?
It brings two things.
Oh, I can see the song. So,
I don't need the song.
no, okay.
Okay?
It connects two words to make them feel right.
Sure. It connects two things. What is the most common conjunction in English?
And!
Okay. I appreciate you raising your hand.
And!
Yes, excellent. So the most common conjunction in English is and that combines two things together, and both of them have, it's the idea of including both of them, right? So in math, when we have a conjunction, we're talking about an inequality statement that has two aspects to it, and both of those criteria must be met for when you graph it on your graph the inequality on your number line. Let's take an example here. 89.1 says graph this. We've got negative x minus 3 is less than or equal to, that's 3, less than or equal to negative 2, and x minus 2 is less than 1, and our domain is integers.
Would it ever say or instead of and?
That'll be the next part of the lesson. It's called a disjunction. We'll get there in a minute. All right, so we have this inequality statement and this inequality statement, and when we graph it on the number line, whatever we put on that graph has to meet both of these criteria. So here we go. Let's work with this part first here. Let's get this so we have x all by itself on one side of the inequality. What should we do first?
Move the x to the other side.
Move the 3 to the other side and make it positive.
All right, somebody says move the x, somebody says move the 3. How many of you want to move the x?
Move the x so that
Listen here, how many of you want to move the x? How many of you want to move the 3? Okay. I'm going to go ahead and move the 3 because that will give me an opportunity to show you something that you have to do. All right, so we're going to add 3 to both sides, just like an equation. And so negative 3, then if we add 3 to both sides, we get 1. And now what are we going to do next? Yes?
Multiply both sides by -1.
That's right. So multiply both sides by negative 1. And
Change the direction.
when we do that, you have to remember to switch the sign. The advantage of going with this suggestion of moving the x is that you don't have to switch the sign.
Ooh.
But you can do it either way. Ours way of doing it, if we were to have added x to the other side, or to both sides, we'd move the x to the right, and then add 2 to both sides. We'd end up with a -1 over here, and this would stay the same here. Do these two things stay the same thing?
Yes.
Yes.
Yeah.
That's
So you could do it either way. So you could do it either way. Now this one here is going to be a lot easier. What do we do?
X.
Add 2.
Remove the 2.
We'll just add 2 to both sides. Nothing majorly complicated there. So we have x must be greater than or equal to -1, and x must be less than 3. So we need a number line.
What's the domain?
I know what to do.
Our domain is integers, so we need a number line. Let's put 0 here in the middle. We've got a -1, so let's do at least one more past that. And we got to get up to 3, so 1, 2, 3. Let's go at least one past that to make sure that we have room for everything that goes on here. Now, am I going to be doing a line or dots? Dots or line?
Dots.
Dots.
2, 3 votes for dots.
Dots.
Because it's integers.
Because it's integers. All right. So we need to be. Can it be -1?
Yeah.
Yes.
Yes. Can it be -2?
No.
No.
Okay. So because x has to be greater than or equal to -1. So can it be 0?
Yes.
All right. We're based on this inequality. We got to start putting our dots. We put one on -1, and then we go to the right, and we just have to make sure we stop here. Can it be 1?
Yeah. Yes.
Can it be 2?
Yes.
Can it be 3?
No.
Why not?
Because it has to be less than 3.
That's That's right, because it has to be less than, not less than or equal to. Since it can't be 3 and it's only integers, we just stop on 2, and there's our graph. Notice that when we have two things that must be true, x has got to be greater than this one but less than this one, what you end up with is an inequality graphed on a line where you have endpoints. You're capped at both ends. Right? With this, my dots here, they only go as far left as -1, and they only go as far right as 2. Let's do an example that has reals. Yes?
Can you put the arrows? I'm so sorry, but
Can you erase the 4?
Thank you.
Because then it'll be equal on both sides.
I'm not going to be so stickler about these arrows. Do be careful when you put the arrows on the end, because what if you're not careful, let's say I didn't have this one,
but you have to put the other one.
this would mean that that it kept going.
Yeah, because that's gross. You have to put the other one and then you're fine.
All right, is this better?
Yeah.
Yeah,
Thank you.
that's
Okay. All right, so let's do example 89.2. We have, and sometimes they can give you, in this case, they started with this statement and then used the word and gave us this one. Sometimes they'll give it to us in one big statement. Let's say that -2 is less than x minus 2, which is less than or equal to 4. And our domain for this one is reals. I'm going to do the fancy R thing. So our domain is reals. When you have it like this, when you have it as one statement, what you want to do is you want to break it off and consider this part. -2 is less than x minus 2, and then consider this part. X minus 2 is less than or equal to 4. So now we've broken it up into the two statements that both must be true.
So you're breaking it with the x minus 2, right?
Yeah, we've got this is being compared to x minus 2 is being compared to this. Well, so when I have it like this, I like to keep the order. I don't like to move the variable around. So I'm going to add 2 to both sides there, and I'm going to add 2 to both sides here. And this also gives me a little bit of a visual. See, I need to consider a 0. I need to consider a 6. So I'm going to go -1, 0, 1, 2, 3, 4, 5, 6, and 1 past that. All right. Now, am I doing dots or a line?
Line.
Arrows, please.
Okay, it's a line because it's reals. Can x be 0?
No.
Yeah.
All right. So what do I do here?
Has to be greater than 0. So.
Yep. So I put an open dot because it's reals.
Or circle.
Sure, a small circle. All right, and I need to be moving to the right. So I'm going to start shading to the right. And what do I do when I get to 6?
Color it in.
I'm going to have
circle.
a solid dot or a filled-in circle because it can include or be 6. I just can't go past that. So there I am.
Okay.
So what I wrote up here for your summary for the formula sheet is, it could look like just a series of dots, or if it's integers, if it's reals, it kind of looks like a barbell. A filled-in dot means that it can be equal to, and an open circle or an open dot means that it's you greater than or less than it's as opposed to equal to. Yes.
We learned that because if you put more lead on the bottom part, you have to fill it in because that takes more lead on your pencil.
Huh.
But can you please put
That
the
works.
arrows for the bottom?
Yes.
Thank you. It's a lot better.
Right. So there you have conjunctions, where you've got two statements, and again, they might give you two separate statements, or they might give you one combo statement that you have to break up into the two pieces. But whatever it is that you graph has to meet both of the criteria. In this case, it was x has to be greater than 0, and x has to be less than or equal to 6. In this case, it was x had to be greater than -1 and less than 3, and so you just have to make sure that you meet both of those criteria. Yes.
For the like summary part, what do you mean like number is less than or equal to x and then x is less than the number? What do you mean? Like,
Some number. If you're comparing x with some number and it can be equal to, then you do a solid dot.
oh,
Because there's more lead.
And if x is being compared with some other number and it's not also equal to, then you have the open dot.
But you could also switch those around, right?
Yeah.
Oh.
I just drew something there so you had kind of an idea of what it would look like if it can be equal to and what it would look like if it can't.
Oh.
All right, let's stop that video, please.